So this video is for graphing linear inequalities. So in the past, we have already graphed lines on the xy coordinate plane. And so now we're going to be graphing them and shading one side of that line. So this is what we would call that a half plane. So in general, what we're going to start out with is we're going to plot the points for that line like we would before, whether that is looking for intercepts, making an XY chart, or putting it into slope-intercept form. Those are all good strategies to be making our points. Next, we have those points. We have to decide if we're going to be connecting those points that are on the line with a solid line, if it says equal to, or with a dotted line, if it doesn't. Okay. The last thing we're going to do is we're going to have to shade one side of that line. So haphazardly, what I mean is if I have this line, I need to decide if I'm going to shade this half of the entire plane or this half of the entire plane. Now that line could be vertical, horizontal, diagonal, whatever, and that would be the case. So when we go to shade, there's a couple different ways to do it. Either use, if it's in slope-intercept form, we can use the fact that one of those variables all by themselves can tell us above or below. The other way is to just test a point that's on one side of the line in the original inequality, and if it makes it true, that's where you shade. If it doesn't make it true, you shade on the other side. Most common point to test would be the origin because of the unique properties. So let's start out with one that's already in slope-intercept form. So what I'm going to do with this one, if you don't remember how to graph a line, in slope-intercept form, y equals mx plus b. We worked with in the past. B is the y-intercept, and that's what we want to do first. Secondly, we move by our slope. Okay, so this particular one, we're going to start off with a y-intercept of 4. And since my slope is a negative 2/3, I'm going to rise over run. Rise negative 2, run 3. Rise negative 2, run 3. I could also go the other way. I could rise positive 2 and run negative 3. Go up 2 and left 3. So these are some points that would be on my line. The next thing we said we had to do was we had to decide if it is going to be solid or dotted. Okay, so looking at this symbol right here, we have to decide, well, is that dotted or solid? It turns out that it is a dotted line, so we're going to connect that in a dotted fashion. Gonna go with that. So I'm just going to, or dashed line, something along these lines. So it looks a little bit more connected than what we had. Okay. The next thing is to shade. And again, what I said was we want to go, y is by itself. I could go above or below. Here y is by itself. It says y is greater than. So if I look at my y-axis right here, where is the y value more than where I'm at? So looking at that, it would be, like say, 5 is more than 3. So we could shade on this half right here, and that would be fine, okay, because that would say above. Okay. The other way to shade it, just to be clear, is we could test a point not on the line. So for example, the origin, or 0, 0, is not on my line. Or I could say check point. If I'm checking 0, 0, I replace the x and the y with that value. So is it true that 0 is greater than negative 2/3 times 0 plus 4? And as we simplify that, we're asking, is it true that x, 0 is greater than a 4? Is that true? No. So should I shade where this point's at? No. You should shade on the other half plane. Okay? So sometimes having multiple strategies is helpful, sometimes it is not. Let's look at another example already in slope-intercept form. If you want to pause the video and try it yourself first, that's great, wonderful. First, this one also has a y-intercept of 3. Then my slope is 7/3, so I'm going to go up 7 over 3. Okay, or I could go down 7, left 3. Okay, dotted or solid. Okay, so we have our points. Done. Step 2, dotted or solid. It's going to turn out that since it does not say equal to, this one should in fact be dotted. So we're going to do our best to give some shape to this dotted line. And then step 3 says we have to shade. So I could either look at that and say it says y is less than, so I would shade below. The other way is to look at a point, say the origin, and see if it's true. Is it true that 0 is less than 3? And it is. So here's the origin. Since that is true, I should shade over that point, which happens to be below my line. And as long as we can tell where you're at, you're good. Now let's look at one that looks a little bit different that's not in slope-intercept form and talk about that real quick. So on this one, we could put it into slope-intercept form. So solve for that variable of y. So I would subtract the x, leaving me a 2y is greater than or equal to a negative x minus 6, but y is not all by itself yet. So I would have to divide by a negative 2. And when we divide an inequality by a negative, then it switches that sign. So negative 1 divided by negative 2 is a positive 1/2. Negative 6 divided by negative 2 is a positive 3. That was not very creative at all. So here's our points. 3. From here I would go up 1 over 2, up 1 over 2, up 1 over 2. Or I could go the other way. The other way to graph some of these is to look for the intercepts. So that would be if I let x be a 0, what is y? Okay, so if that was a 0, so I know it makes it true, or divide by negative 2 and get a 3. So my y-intercept is at 3, and my x-intercept means that y is a 0. Therefore, x would be at negative 6, which is where it's almost down to 1, 2, 3, 4, 5, negative 6 down there. Which is in line with my other points. Those are 2 different ways we could be graphing that. We could also have done an XY chart. So from here, we need to, doesn't work out so well, to have a solid line because it says are equal to. So this means it's solid. Or I could even look up here and know it's solid line. Then we have to decide where to shade. Now, if I'm going to decide where to shade, it's kind of tricky because if we forget to flip our sign, we might not have it right. We would have to go by the final sign, or we could test the point 0, 0. So if I test the point 0, 0, is it true that 0 minus 2 times 0, I think it's 0, is it true that that is greater than or equal to 6? Yes. So where the origin, or the point 0, 0 is at, is the side I should be shading on, which is also below my line. But again, just depends. Reminder, if your variable, your inequality only has one variable, we still want it to be graphed on the xy coordinate plane. So if it only has that variable, that's the axis it crosses. So the x-axis at 5, it's a little bit off the charts here, so we want all the points that have an x-coordinate of a 5, which is this whole thing. But it is dotted because it doesn't say equal to. And where are the greater values of x? Well, is 0 more than x? No. So it would just be over here. If I had y is less than -1, it's only going to cross the y-axis. That one is solid because those are equal to. And my lesser values of 1 is 0 less than -1. Nope. Less than is below. Okay. So this was all for linear inequalities on the xy coordinate plane.